I've always wondered what kind of a technology we need in real life to mutate a human into a chameleon-man or a Hawkeye for the superpower of invisibility or seeing beyond, like Spider-Man, but for real. What kind of scientific knowledge would we honestly need to achieve for this kind of tech? Hawks can see 5 times better than human beings. But how do we know that? In this video, we shall focus on this question. This is the Let's imagine you have a pet hawk on your shoulder and you walk in a desert. The only thing you can see is the sand dunes, sky, and a cactus plant over there. Is this all there is, or is this all you can perceive? I mean, does your hawk see exactly the same? She got 5 times sharper vision, therefore she sees a lizard on the cactus, crawling between the spikes of the plant, whereas you barely can see the plant. Psychophysics is the science of the relationship between a physical stimulus and sensation, psychology and physics. The physics portion refers to the physical world, stimuli, the dunes, and the cactus, and the psycho prefix refers to the psychological process of perceiving. We want to measure the perception and its limits. Why you can't see the lizard while your hawk can is explained by the concept of the absolute threshold. Absolute threshold is the smallest stimulus level that can be just detected by an observer, the minimum, the smallest, the dimmest light, or the faintest sound. Humans can hear about 20 Hz, so that is the absolute threshold of hearing. Gustav Fechner wrote this book of Elements of Psychophysics in 1860, in which he proposed 3 methods for measuring threshold: the method of limits, the method of constant stimuli, and the method of adjustment. In the method of limits, the experimenter presents stimuli in an ascending or descending order. Starts from the intensity of, let's say, 103, and the participant says yes when she hears the tone. Then the experimenter gives 102, then 101, then 100, 99, and so on. Each time the participant confirms by saying yes. When the participant says no, it is marked as a crossover point, and the threshold for this series is taken as 98.5. Next time the experiment starts from, let's say, 95. The participant says no and goes up 96, 97. When she hears and says yes, we have a slightly different mean, like 99.5. The experimenter does this in an ascending and descending orders and calculates the mean of each crossover. Thus, the result is the absolute threshold by using the method of limits. In the method of constant stimuli, the intensities of stimuli are presented in random order. That's the only difference. It would have been better if they called it the method of randomness or something, because, it's random. The third one is the method of adjustment. In this one, you give control to the participant. She adjusts the stimulus intensity by herself, continuously until she can just barely detect the stimulus. There are some advantages and disadvantages of these methods. The method of constant stimuli is the most accurate because it involves many observations, and stimuli are presented in random order, which can minimize the effect of one trial on the participant's judgment of the next trial. This can help to reduce bias and increase the reliability of the results. The disadvantage of this method is that it is time consuming. Also, you have to know what the threshold is approximately going to be before you start, so that you can choose stimuli of several values. The advantages of the method of limits are that you don't need to know where the threshold is at the start. It is efficient because when you find the first crossover, you can concentrate on this area for faster results. The method of adjustment is the fastest because participants can determine their threshold in just a few trials by adjusting the stimulus intensity themselves, but it is not so reliable. Another threshold we will learn is the difference threshold, the smallest difference between two stimuli that we can tell the difference between them, also known as just noticeable difference, or JND for short. The first one is Weber's law. Weber's law is the mathematical equation to quantify the just noticeable difference. It states that the just noticeable difference between two stimuli is a constant proportion of the original stimulus. It is not a constant amount of change, but it is a constant proportion of change. Let's make an experiment. Now I will either add or remove one dot. You probably cannot tell the difference when there are too many dots because one dot becomes too small of a fraction of just noticeable difference. That's the Weber's law. Fechner's law is built upon Weber's. It is how the perceived intensity of a stimulus changes as its physical intensity changes. He realized that just because the physical intensity of something changes doesn't mean that perception of that would change the same. There is one light bulb here with a, let's say, 10 intensity of light. So two light bulbs must have 20 intensity. But perceiving this light, according to Fechner, would be like this. Yes, you will have twice as electricity bill, but what happens to brightness? The perceived brightness here corresponds to this graph. Two light bulbs will appear brighter, of course, but not as twice as brighter. If the first one is judged like 10, the second will be 12 or 13. The last one is the Stevens power law. After 100 years of Fechner's law, Steven wrote this article claiming a power function, not a logarithmic function, describes the operating characteristic of a sensory system. It means that Steven argued that Fechner's law was only sometimes correct, not every time. It only worked for some of the perceptions, like brightness. Steven also confirmed that when the intensity of light was like 20, the perceived brightness was 28. If we double the intensity to 40, the perceived brightness wouldn't double to 56. It will be 36. Remember, that was the Fechner said, and it was correct. But what about electric shocks, Steven thought? If we increase an electric shock presented to a human's fingertip, and he did, from 20 to 40, the perception of shock magnitude will increase from 6 to 49. We don't give the same responses for every stimulus. That's basically Steven's power law. In the part 2 of Psychophysics, we will learn signal detection theory. Thanks for watching.